Hallo. Na?
Und aufgeregt?
Ein bisschen.
Was schaffst du? Siehst schon mal so aus.
Okay. Cool.
Super. Wenn du magst, ich hätte auch.
Mhm.
Habe ich das jetzt dabei? Das kann man natürlich klauen. Ich habe das Smartphone eingepackt. Das war. Also,
Okay.
ich wasche mir mal die Hände.
Test, 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 Test. Stretch. Okay. Das Einzige, was nicht zu funktionieren scheint, ist die Sache zu muten. Aus irgendwelchen Gründen. Ich verstehe nicht wieso.
Wo ist denn das Giga-Mikrofon hier? Da?
Ja, das habe ich ja eigentlich zu Hause stehen für so ein paar Seitenprojekte, aber irgendwie. Wahrscheinlich muss man das immer hier einmal abdrehen, damit man irgendwie nicht gehört wird. Strange, da war das Ding extra ein Mute-Button. Ah, anyways. Gut, auf jeden Fall funktioniert das. So.
Das Ding ist auch gleich USB.
Genau, das USB und du kannst irgendwie einstellen, ob du es irgendwie aus einer Richtung willst oder aus beiden Richtungen oder aus allen Richtungen oder. Das ist eigentlich auch ganz cool. Ja. Gucken. So. Was machst du eigentlich?
Ich bin tagsüber leite ich das Entwicklungsteam bei einer kleinen Schweizer IT-Bude.
Okay, cool.
Wir machen mehrheitlich sammeln wir Daten im Internet ein und machen das für andere zugänglich. Das sind vor allen Dingen so im Immobilienbereich sind wir da tätig.
Cool.
Also wenn du wissen willst, wo alle Mikrofilter sind und wo alle Bushaltestellen
sind. Dann habt ihr das.
Das ist das wir so machen.
Das heißt, ihr geocodet die Sachen.
Genau. Das ist der Raum. Da kannst du ausrechnen, irgendwie, wenn du eine Adresse hast, kannst du ausrechnen, wie weit das Zeug weg ist. Und wir gehen aber immer mehr eigentlich in Richtung Datenaufbereitung, Datenveredelung und so Zeug. Oder die meisten, also da ist halt ein Fehler drin und in allen möglichen Sachen irgendwo oder das Verknüpfen mit anderen Daten.
Klar.
So. Cool. Und ich war jetzt aber die letzten, also von einem Jahr zurückgekommen, oder die 3 Jahre davor, im Silicon Valley.
Okay,
Und da auch das Interesse ein bisschen für Spark und so Sachen.
cool.
Und da habe ich mir noch so ein Hobby mitgebracht. Schauen wir mal, ob ich Also mit Tobias haben wir uns so nachgedacht, ja, was ist denn das? Ich habe mir überlegt, das eigentlich so zu verlängern. Das ist aber relativ viel Klasse. Das ist besser. Ja, das ist Gefühl, das überhaupt nicht schreiben. Das erste Jahr mal. Mit einer bestimmten Themen zu einem Bevor. Ja, was ist das? Also extrem normal okay. Und vorletzten Mal, weil es ein bisschen für den Mal eigentlich immer geht. Hi everybody, this is the Spark Meetup. As you can see, thanks everybody for coming, and it's a very sunny day. Maybe some folks are already on vacation. I met Rene a while ago, and he told me that he'd been at the Spark Summit in San Francisco, and I don't know how many people went, but I thought this would be a good point to actually have a look at what happened there, get some first-hand insights. And what kind of happened in the past and what's the outlook. So he kindly agreed to give us his presentation. So we've got a microphone there. We'll actually online stream just the slides and what he says or not on camera. Afterwards, I asked the Impact Hub to put some beer in the fridge, so whoever wants to hang around, I see somebody that just grab one and pay. And I also put some chips and nuts out there, so we don't have to run off afterwards. Rene is at NZZ. So I'm surprised how many actually companies in Zurich and around already use Spark. So when we started it about a year ago, kind of hadn't knew anybody, but they are. So they've been using Spark for a couple of years now. So I found those examples. Okay.
Cool.
Thanks, Rene.
Thanks. Yes. So first, let's see. Okay, so let's see whether I see you, because the sun actually is really good, but unfortunately we can't do anything about it. So yes, thanks for the invitation. Welcome. As we said, the whole thing will be streamed. Hello, Romeo. So actually he's the one who wanted it to be streamed, because he's not here and he's on holiday, but he anyways wanted to watch it. So also as you see, I'm trying out Google Slides at the moment, and they have this feature that you can ask questions online, and then I have a presenter view and I see the view. So if you're shy and you don't want to talk to me, so you can also grab your smartphone and kind of ask the questions there. Or Romeo, you could ask questions online. That's especially for you. Okay, cool. Yes, so let me reset this and let's go ahead. Yeah, so thanks. First of all, just a few words about myself. So I'm Rene. I'm the lead data scientist at NZZ. There I'm basically responsible for customer analytics and like everything algorithms, so to say. If you want to get in contact with me, see below. And if you want to talk to me after the talk, on the right side you find a couple of things that will trigger my interest for sure. And then actually, before I start, there's another shameless plug. So actually, I'm looking for a machine learning intern for the summer months. So if either you're interested or you know anyone who is interested in that, head to this site or shoot me an email. Basically, we will be doing a lot of coding prototyping when it comes with respect to deep learning, TensorFlow, Spark, of course. So if you know anyone who's interested in that, bachelor, master student, tell him or her that he or she should apply. Cool, so now let me get my speaker notes. Okay, so before I start, I'd like to get to know you a little bit. So let's do the following. Can you please raise your hand if you don't know what Spark is? Good, nobody, okay. Can you please raise your hand if you know what Spark is, but you haven't actually tried it? Okay, so that seems to be the majority then, actually. So please raise your hand if you have prototyped a little bit in Spark. Okay. 1/3. And who of you is using it in production? Okay, good. So that's like 5 people. Cool. So what I'm going to do is actually I'm going to present you a few of my key learnings from the Spark Summit in San Francisco. That took place last month in San Francisco. So basically I will present you 6 trends or new features or what's coming up that I will going to present you. This is going to be a little bit more technical. And then I have like 4 insights and key learnings. Many of you will have heard about them already. But anyways, I think they're good to mention again and to know. So in this sense, we are kind of going from more technical and more advanced to less technical and less advanced. Also, let's see about time, what we can do. Okay, so let's go first. So for those of you who actually don't know what Spark Summit is, it is a community conference. It's organized by Databricks. Many of you will know Databricks, the leading company, let's say, behind Spark. The first one of those actually took place in San Francisco in 2013, and it has been actually every year taking place, always around June. And last year, actually, there are 2 more Spark Summits joined. So there's one at the East Coast in New York City in February, March. And there's also one in Europe. So last October it was in Brussels, and this October it's going to be, no, the other way around, it was in Amsterdam, and this October it's going to be in Brussels. So yeah, if you're interested in that, it's a 2-day conference with 1 day of workshops, and it's really worth it. Okay, another very important thing actually is that if you don't have much time, or I don't know, you don't like listening to me, you can just leave and actually go to that webpage, because they actually opened all of the content to the world. So for all of these Spark Summits, all slides and videos are available. I highly recommend watching it. It's a couple of 100 hours of material. So if you don't know what to do on the weekends, I'm sure you will be able to spend a lot of time there. Okay, good. Also, of course, I will make those slides available. So no need to take fussy pictures. Okay. So let's just go ahead. Trend number 1, Spark 2.0. So who knows that Spark 2.0 actually is coming up? Yeah, few. Okay, that's what I thought. So as you know, at the moment we are at 1.6.2, and 2.0 was supposed to be like up and running already in March, and then when I have been at the conference, they said, well, it's going to be later this month. So now it's July already. So I guess they have a couple of bug fixes to do before they're actually going to release it. So yeah, it's going to be out soon. And as you realize, it's going to be a major, actually the first new major version number. So does this mean there are going to be major changes? Yes, of course. Does this mean that those changes will break your code? No, they won't. So there are only a few things, maybe 1 or 2 things, at least that I understood, that might be a bit problematic, but then you can actually change them in your code with like 1 word. So if you have code in production or whatever, and you want to transition to Spark 2.0, it's not going to be a big problem. It should be, at least. That's what they say. So actually, there are many improvements. So overall, there are like 2,000 patches that will go into this new release. There are many, many improvements. I'm not going through all of them. As I said, it's highly compatible to everything 1.x. That's important to know. But actually, there are like 2 things that really, really stick out. And those are the 2 things I'm also going to spend the next couple of slides on. So the first thing is Project Tungsten. So who of you has heard of Project Tungsten? Okay, so for who of you who haven't, Project Tungsten really, they started with 1.3 or 1.4. It's an initiative to make Spark even faster, or to make it faster. And how do you do this? Well, you use structure that might be in the data. So that's like one of the things. As you might realize, the data frame API actually also got released in Spark 1.4, because it's like the first outcome actually out of Project Tungsten. And Spark 2.0 really is supposed to be the next stage in Project Tungsten. So there are going to be 5 to 10 times performance increases for the structured APIs due to something they call whole stage code generation. If you want to read more about this, check out the reference or just Google it. The next thing is actually there's going to be a structured streaming API. So those of you who have been playing around with Spark streaming, yes, you can do it, but you are not able to use the data frame API, which is kind of sad. So this is something that is going to change. There's going to be, so to say, a streaming data frame. I will talk about this a little bit later. And most importantly, there is a change in the structured APIs. So actually in 1.6.0, data sets were introduced. And especially when you start wrangling with Spark, you have like those APIs and you don't know which to use. So there's like RDD APIs, and then there's data frames, and then there's data sets, and so which of one should you actually use? This decision is going to become a little bit easier, because with 2.0 the data frame and dataset API will be combined. And I'm going to talk a little bit more about this now. So actually, as I figured there might be many people who don't have so much Spark experience, I really want to explain what is the difference between an RDD, a data frame, and a data structure. Of course, all of this is best done when you actually look at code and things like this. There will be a short demo. I'm trying this. Let's see. Let's cross fingers whether this works, on the difference of data frames and data sets. But yeah, so I'm going to spend the next 10 to 15 minutes on this. Okay, so unfortunately, I'm not. I mean, I can't go too deep, but so RDD is basically the most basic and versatile API. So when you start learning or reading about Spark, RDD is the first thing you certainly read. So, and this is also the API you will use. There you have like the MapReduce familiar map and reduce functions and so on and so forth. So if you're transitioning from MapReduce, basically, that's like the most, let's say, familiar to you. However, because of its versatility, there is actually not much optimization that is possible that you can do, or I should be more precise, that the Spark engine can do under the hood. Which is then actually why Project Tungsten was initiated and data frames were introduced. So data frames are basically, well, basically not, but conceptually they're equivalent to tables in a database. Okay, you have a schema and you have all the data in the schema. So it's well behaved, it looks nice from a human point of view. So it's a representation of structured and even semi-structured data. So you can put in JSON, also nested JSON, and it will handle it. The point is why you do this. You do this because then actually Project Tungsten and the Spark engine actually can optimize the code. So it can make it more memory and CPU efficient. What this means for you as a developer, the first choice of whether you think, okay, which kind of data structure should I use, RDDs or data frames? If you have structured data, you should always use data frames because you not only have a powerful high-level API, like the Spark SQL kind of thing, but it's also faster and more memory efficient. Okay. Also, many people think that actually data frames are RDDs of rows. That's mainly because if you have a data frame and you call the method RDD, you will get the RDD back, which is an RDD made of rows. However, internally, it is not really a RDD of rows. It's much more. One thing that's going to be important now, it's not strongly typed. So, but that's something that we are going to do here in a second. And on the right-hand side, you actually see the graph. So that's like from version 1.4. You have a comparison between the data frame and the RDD API, and you see that the data frame API is in the best case 5 times, and in the worst case like 2 times faster for certain operations. Okay, so now we have like 2. We have RDDs, we have data frames. We know data frames are optimized, so you should use them, plus you have a high-level API. The next thing actually that was introduced in 1.6.0 was dataset. That is basically a merge between the twos. So if you want to be very kind of sloppy, you could say that a dataset is a strongly typed data frame. Okay, what this means we'll see in a second. But in general, it's a strongly typed structured data collection, whereas RDDs are strongly typed and versatile, but you don't have the structure, you can't do much optimization. Data frames are weakly typed, but they are structured, so you can do optimization on it, and data sets kind of combine both. From those of you who are using Spark, we have been using Spark, did you actually use data sets so far? Just raise your hands if you have been using data sets. No? Yeah, okay. So because actually the thing is that the API at the moment is, okay, I mean it basically looks like the RDD API, there's not much into it. This is going to change, but more on this in a second. So as I said, data sets, it's a little bit complicated to understand, but what I want you to know is basically, let's say, from 2 perspectives. From the developer perspective, what you have to know is it's strongly typed and structured, which means it's faster and it's more memory efficient. But it's not directly implied by this, but if you have those properties, then the Spark engine can do this, and Project Tungsten does this. Plus, actually, there is a new concept that hasn't been there before. It's called encoders, and it's there to speed up serialization and deserialization, and you see it speeding it up by factor 20 or so. So actually, that's the big deal about it. Okay? From a data scientist, let's say an application perspective, data sets will look like data frames and RDDs. So you will have all the lambda function possibilities, filter map, flat map that you have in the RDD, and you don't have in the data frame, you have this in the data set. Plus, you will have like all those high-level features that you have in the data frame API that you are not having in the RDD. And also, what is very interesting and important to know, you can easily convert between data sets, RDDs, and data frames. So, why this is the case? Okay, to make things a little bit more, let's say, I don't know, to grab them a little bit more, I found this sentence in this book, High Performance Spark, which is available on Safari Online already, but it's actually not released yet, it's a preview. And it says the following. So one of the reasons to use data sets over traditional data frames is their compile time strong typing. Data frames have runtime schema information, but lack compile time information about the schema. What does this mean? Well, if you remember, if you have, so sorry for those who haven't used Spark so far, but if you have used Spark, if you call a data frame, you don't have to give any, or if you are reading a data frame, you don't have to give any schema information. It's basically inferring this. However, this means that also at compile time, no schema information is available. It's only available at runtime first, which is bad for certain tasks. And as they go on, this strong typing is especially useful when you make libraries, because you can more clearly specify the requirements of your input and your return types. And your compiler can actually check already whether all the things kind of fit together. Plus, there's one more thing. If you are wrangling terabytes or even petabytes of data, and you actually know the structure, you should use data sets, because then, you know, I mean, you don't start firing up, but you kind of have to check at the compiler level already whether this is going to work. Okay, so what do I want all of you who are starting to use actually Spark to take away? If you're still wondering RDD, data frames, data sets, use data frames and data sets if you have structured information over RDDs, because they're memory efficient and, or basically they're optimized, memory efficient, CPU efficient. The big thing in 2.0 really is that in Spark 2.0, the data frame and the dataset API, which at the moment looks actually pretty ugly, is going to be merged. So I just want you to take a look at this. So this is like the dataset API that has been available in Spark 1.6.2. And you see there's actually not much. It's basically everything, well, somehow that an RDD can do. However, there's a preview available for 2.0, and what you will realize, the API kind of blew up. It's much more. If you check here, you will find the familiar functions that you have in the RDD API. You will find familiar functions that you have in the data frame API. And if you read here, this is a very important sentence. Each data set also has an untyped view called the data frame, which is a data set of rows. So actually the data frame as it's kind of existing today will not exist anymore. It will be a data set of rows. So in this sense, in the future, every one of us will deal with data sets, because if you are dealing with a data frame, you're going to deal with the data set basically implicitly. Okay, good. So, whoops, sorry. Let's go back here. Now let's go to the exciting part, the demo. Let's see whether that's going to work out. So, I actually have another one open here. And it should mirror what I do. Excellent, it's mirroring it. So now you see I attached a data frame. I attached the cluster. So actually, this thing is also something that was highly advertised at Spark Summit 2016. It's especially interesting for those who are going to start using Spark and for those who are at the prototyping level. There is a community edition from the Databricks Spark Cloud Platform. So basically, you can sign up for free. They give you a cluster for free with like, I don't know, 6 gigs of RAM and 3 nodes or something like this. And you can basically play around with everything without having to wonder about, I don't know, setting up your own cluster and then all the configurations and stuff. Okay, so what I want to do is actually, I want to show you a little bit of the difference between data frame and data sets, and one particular reason why I think data sets are useful. Okay, so for this, actually, we first read the data, so in a familiar way. good, so it's working, excellent. So we take the SQL context, we say read, and then actually I put some data in S3, and it's JSON data. So okay, we have this. So we're calling it, it's sitting here, and then we're basically showing it. Let's see what's going to happen. Okay, so it takes a while because it's firing up the Spark context. Okay, now it's running. Good, so there we have it. And I should scroll. Good. So here we have it. Basically, it's a small data set. It has 3 rows. It's some constants. Okay, good. So now actually, what I want to do is, let's say you have this data frame and you want to transform it. So let's say you want to take the two columns and you want to form a whole sentence out of it. So actually what you can do is there are like 2 possibilities in the data frame language. So the one is either you look at SQL functions and you find a function that does exactly what you want to do, then you can use it, or you have to go and write your own UDF, which is more work, and I'm lazy, so I try to avoid work. So yeah, you would have to do this as well. So the point is, at data frames, you don't have Lambda functionality as you have at RDDs with like the MapReduce kind of thing. Okay, so in this case, I'm lucky because there's a function, it's called concat. It's going to concatenate strings. What I'm going to do is basically here, I'm going to call the columns. So one is called constant name, okay? And I want to concat this with is, and then I want to say constant value, okay? Cool. So now actually, if you know this, actually, the function concat function, it takes as inputs columns, so I cannot just basically put the literal is there, but I have to say functions.lit, which transforms is into a column that only says is, basically in all the rows. And I'm going to run this. And okay, that's fine, so this worked. So I got a whole sentence. It's called unit is 1, pies, and so on and so forth. Okay, good. So now, actually, I would like to do this using the dataset API. Good. So then again, actually, it's going to be very easy. I'm going to my SQL context. Okay. I'm going to do exactly the same thing as with data frames. I'm going to say read. I'm going to say JSON. So actually, until here, let's see whether it actually does this. Oh, excellent. This is cool. So until here, this looks exactly like if you would read a data frame. Okay. So now what you do is actually, you say, well, but I don't want it as a data frame. I want it as a data set. And what you do is you actually say s, and then you give it some structural information. And this structural information is going to be a case class. So you define a case class. You say, okay, I have one object that's called constant name. It's a string. And I have one that's called constant value. It's a double. You define this, you say .s, and then you say show. Okay, and please observe, you say show and not take. So it's not really like, it's not an RDD. Or I could say take, because it's also, I mean, it also has the RDD API function take, but I'm more interested in using show because I get the table, and you see, there it is. I read the data, but now as data set, as you can see right here. Okay, good. Right here. Okay. So now I want to do the same transformation as above. So remember, with the data frame, you know, you had to check for the UDF or the functions that are there already. And that's quite cumbersome. And I promised you that you can use actually the Lambda kind of functionality. And that's exactly what we're going to use here. So we are going to say, okay, that's X. That's called constant name. Constant name. And then we just basically append this. and then we say x dot, constant value, and we say show. And what we get back is a data set with exactly this. And I think all of you agree that this is much nicer than this. So that's just one example, basically. Yeah. So because of the time, let me just go on with the talk. Yeah, so the other things we can go through if there's time or if you have any questions. Okay, good. So this was trend number 1. Trend number 2. Trend number 3 is streaming 2.0. So who of you actually has been using streaming? Not, yeah, a little bit. Okay, good. So so here's the take actually of the Spark community about streaming. The simplest way to do streaming analytics is when you don't have to worry about streaming. Sounds very reasonable to me, and actually they are up to their promises. So actually this goes into the same direction of what they always keep telling you, and if you start reading, that Spark is really supposed to be an end-to-end analytics platform. So if you do ETL somewhere else, you're doing something wrong. Okay, everything is supposed to be in Spark. This is what it's made for. So what actually is this streaming 2.0? So far, actually, so at the beginning, Spark streaming, as you know, is micro-batching. It's not really streaming in the sense that you're waiting for events and then things get triggered. It's micro-batching. So you basically define small window sizes, and in those batch window sizes, you do something. So far, what you do is actually you call a stream context, and this stream context provides you with these streams, and these streams are basically sequences of RDDs on which then you can operate. However, as they are RDDs, you can't use the really nice data frame API, which is so user-friendly. Of course, if you want to, you could convert those into data frames, but you know, it would be much nicer if it's kind of natively supported. Also, if the data that is coming in your stream is structured, it would make sense to use it to kind of have it as a data frame, because then you can make use of all the underlying optimization that the Spark engine is taking care of for you. So this is actually why they came up with the concept called structured streaming. And structured streaming really is nothing but the following. So, so far we have like static bound data. So you have data, you read it, you have a data frame, it sits there, fine. The structured streaming really means is that you have an unbounded data structure. So you have a data frame that can grow, which is kind of nice. And what is even more nice, it's one single API. So the left data frame and the right kind of streaming data frame are for you. As a user perspective, you can't really you can't really distinguish them. So you have the same API, the same functions you can use, and so on and so forth. So I prepared a little demo, but this demo unfortunately doesn't work. It used to work. I don't know why. Might be that actually they reverted some, I don't know, something in the current branch. So, but it didn't work. But anyways, so this is then at the end how structured streaming should look like. So remember they said you shouldn't worry about streaming if you want to do streaming analytics. And this is really what's going to be here. So you call a structured stream the way you would actually call a usual data frame or data set. The only thing you append is you don't do a .read and then source path if you're reading, let's say, from HDFS, but you say .stream. And then what it's going to do basically in certain time intervals that you can define, it will check whether there's new data, and it will put this data then actually in the data frame that's sitting in your SQL context. Whoops, okay, this was too fast. Sorry. Let's go back. Yeah, that's sitting in your SQL context. And then basically based on this, you can do all kinds of things that you're doing with data frames already. Plus, if you're fancy, actually, you can not only save it once, But you can say, okay, save, start, stream. So you continuously save these things also with a given time interval, in this case to a Parquet file, or you can write it, I don't know, to whatever JDBC connection you have. Okay, so that's Spark Streaming 2.0. It's going to be awesome if it's going to work like this, but let's see. Yesterday night it didn't work. Okay, trend number 4, and that's also out of personal interest and curiosity. There is a project called Graph Frames. So who of you has been doing graph analytics with Spark? Okay, good. So I can tell you that actually the recommendations we serve are based on a graph approach using graphics in this case in Spark. So yeah, so up today, so you have graphics as the graph, as the graph analytics project in Spark. It's based on the RDD API, and from my perspective, it has a rather steep learning curve. It's not very intuitive. However, there is a good set of implemented graph algorithms. So you can use, I don't know, you can run PageRank and belief propagation kind of things as you like. The nice thing is it also has Pragle implemented, which is a general kind of message passing language, so to say, which is cool, especially as you can implement most graph algorithms using a message passing scheme. However, they are not really good and not optimized for graph queries. So if you want to query your graph, of course you can do it, but it's not really fast or good or anything. So this is why actually some people started graph frames. Again, it's, as Spark was, a PhD project of someone in the AMP lab. It's very early stage. It's version 0.1. Also, you see that the documentation, there's not much in there so far. However, the idea is really that you base graphs also on data, on the data frame API, which again is optimized and better to use. Which also then comes with a nice feature that you can do graph search pretty well. So I would recommend, if you're interested in graph analytics of any kind, please watch it. And to give you an idea, there's a demo. Okay. Good. So the streaming didn't work. Okay, so graph frames. Yes, so it's actually going to be fairly easy. So if you want to define a graph, what you need are vertices and you need edges. Okay. So what you do simply here, and this kind of reminds a little bit about iGraph and R, maybe, is that you can, so you import graph frames, and then the only thing that you do is actually you define a data frame, or you read it from whatever file you have. In this case, it has basically 3 columns, so there has to be an ID, a unique ID. This is the only thing that's needed, and then you can give it properties. In this case, it's name and age. Okay, so let's just run this. Okay, good, and we got a data frame of this type. Nice. Okay, so next thing. So now we have our edges, now we have our vertices, now we need edges. So we do the same thing. We create a data frame. In this case, this data frame needs to have the 2 columns source and destination, plus as many kind of features or qualities as you like. So we run this. Oops, okay, and I wanted to show you. Okay, and we got a data frame basically that holds those edges. So in this case, A and B, which is Alice and Bob, they will be friends, and B and C, which is Bob and Charlie, they are following each other, and C and B is also following. So you see already, okay, it's a directed graph. Or it's edges of a directed graph. So now the only thing that's actually left for you to do is this, and it's almost embarrassing because that's the demo. Whoops. Okay. Oh yeah. Okay. Sorry. I know why, because I said show. So we don't want to show. That's right. Okay. So we define them, and we say there's error. Voila. We got back a. Whoops. Where is it? Yes. So I just ran it, and we got back a graph frame. And then basically on this graph you can do all kinds of things. You can ask, for example, for the integers, and we can do that show to actually also see them. And you got back a data frame with the integers. And you could do the same thing, so you could use a filter, and then you could do PageRank and whatever you like. Okay, so this seems fairly easy and fairly nice. And it's definitely a project to watch. Okay, so trend number 5, Spark R. Anyone using Spark R? Yeah, I think like trying around. So Spark R is actually catching up. So Spark R is another API, another way to actually, yeah, you could say so. No, not, yeah, actually. So another way to interact with Spark natively in R, which of course is nice if you're used to R. From my point of view, there are actually 2 ways how you can see Spark R. You can see it as a really convenient entry point for the data that might be sitting anywhere, let's say HDFS, and you can't actually just get it to your Spark session. And especially then if you are, let's say you want to do visualizations, you never need like all the terabytes or petabytes of data, but you usually work on smaller aggregated data sets. So what you can do is you can just fire up a Spark R, or you can just fire up Spark R within the R shell, and you can basically aggregate the data as you like, and then you might aggregate your data, like terabytes of data, down to maybe a few hundred megabytes or maybe 1 or 2 gigs. And then what you can do is actually you can collect it back into your R context, which is nice because then you just have a usual R data frame and you can do everything on it and with it what you like. So that's the first way to see it. The second way really is Spark R as a complete API for data science and especially predictive. What this of course means is that, well, now you have like MLlib, which is the machine learning library in Spark. You have a lot of nice models implemented there. You would like to have all those models in Spark R, and actually it's an ongoing effort. Models are getting implemented more and more. The newest ones are generalized linear models and k-means. So you should definitely also check it out if you're fancy with R and you like Spark. Also, one thing they said is that actually soon it's going to be on CRAN. So, which is nice because it makes installation easier and stuff. Okay, trend number 6. I only have 1 slide on this. Deep learning. So deep neural networks are coming, and especially they're also coming to Spark, and you should watch out. So there have been many talks, and I talked to many people, and also I went to a workshop earlier before the conference on how you can use TensorFlow in Spark, Caffe in Spark. So there are projects, there are good sites out there, very nice tutorials. So if you want to play around with deep neural networks, and especially TensorFlow, yeah, and you want to combine this basically with R and the parallel computing capabilities, the Spark and the parallel computing capabilities of Spark. There are some projects that combine this, and you should watch it. Okay, good. So those are actually the trends. So this was like the most technical part, and now we are getting a little bit softer somehow. So insight number 1, so that's really like personal things I felt is there are many big players actually using Spark. So if you thought, it's like this project, you know, there's like Databricks, but no one else is using it, it's not really true. Of course, there's the MPLAB and Databricks, which are like the two driving factors in the development of Spark. Airbnb is using it for streaming, Uber is using it for streaming, Netflix is using it heavily, and if Netflix is using it and they have like huge amounts of data to kind of work on, that's already a big thing. Especially Netflix, what they said, they're a heavy committer to the Parquet support in Spark. So if you are starting Spark and you are wondering, what kind of file type should I put my data in HDFS? Should I use like Parquet or Avro or JSON or CSV or whatever? You should definitely use Parquet. It's the primary choice for Databricks. For Netflix, it's just got faster actually, or it will get faster in the 2.0 release. Actually, they said that there is a Parquet I/O performance increase of also 5 to 10 times. So definitely use Parquet. Also, like the traditional ones like IBM and Microsoft, they're kind of slowly but steadily jumping on it. Yes, so that's insight number one. Insight number two, I personally felt, so actually we haven't been using Spark for the last years. Actually, we started like a year ago. It's quite a steep learning curve, especially there are so many things to take care of. Yes, the APIs are fine, they're kind of nice, and if you have a SQL background, especially when you use the data frame API, it will be very familiar to you. You can more or less immediately use it. However, when it comes to tuning all the things, so you have to do a lot of reading. The good thing is you are not alone. Same issues everywhere. Google and especially the Spark user mailing list is your best friend. So that's just one thing I wanted to say. Don't worry, everyone basically has gone through this. Insight number three, so that's something I got from a workshop previous to the conference. Use Spark streaming for what it's used, for what it's made. So basically stream, compute, and dump. Don't do the following. So actually there are some people who try to do the following. You have a streaming job, okay, that's fine. You create a data frame, okay, that's fine. You create a temporary table, and then that temporary table you actually serve in production using the Thrift server, and you expect to get good performance out of this. So it's not going to work. You should really use Spark for what it's meant for, namely real-time computation, not serving. So really, again, what you do, stream the stuff, compute it in Spark, and dump it to a database. Maybe Cassandra or whatever you like, if it's going to be. So. Okay, insight number four. So this is a few best practices, and so one thing you find when you start using Spark also is, yes, there are many blogs out there and many tutorials, but most of them are very basic. So they tell you, you have like a Spark context and, how you read data and so on and so forth. But when it gets a little bit more complex, there's hardly any best practices out there, like in a very concisely written form, I felt. So this is a little compilation. Some of them also, they have been kind of rehearsed at the Spark conferences over and over again, because you really have to know them such that you can avoid certain problems when you encounter them. Number one is there's group by key. Should you use it? Well, there's group by key. So what does grouping mean? Grouping means shuffling. So if you have data sitting in your HDFS, and those are key value pairs, and you want to do a group, what Spark is doing, it's basically finding, in this case, all the A's, all the B's, and all the C's, and it's putting them basically in one executor each. So there's only A and B, no C, sorry. So all the A's, all the B's, and all the A's are going to one executor, meaning to one machine. All the B's are going to one executor, meaning to one machine. Of course, on the one hand side, this takes time. On the other hand side, you might actually run into a problem that this thing doesn't work at all for you. Because if you have something that in the Spark community it's called data screw, and I'm going to talk about this in the next slide, which basically means that if you have many, many more A's than you have B's, well, you might run out of memory. So actually it's not going to work, which also means that after you group by, you cannot do your reduce function. In this case, what you want to do is you just want to count all the A's and all the B's, or you basically want to sum up the values associated to the key A and B. In this case it's 6, in this case it's 6. However, if your reduce function, in this case the sum, is associative, and the sum is associative, then you should use reduce by key. Because, and here unfortunately you don't really see it, I'm sorry about that. You don't have to first collect everything basically on one executor. As this function is associative, you just can take all the A's and sum that up. Whoops, sorry. You just can take all the A's sitting here and sum them up, all the A's sitting here and sum them up, all the A's sitting here and sum them up, and then collect them, basically those sums already, and then sum them up again. So I just ran in this like really 4 days ago, so that's not true, I was on holiday 4 days ago, it was like 2 weeks ago. My colleague, so he used group by key because he wanted to do more or less exactly this, he wanted to count. And he used group by key, and I say, I don't know what's going on, and I say, well, little Padawan, it's very easy, you should use reduce by key. Okay, good, so I quickly mentioned this thing called data school. So data school really in this context means the following. If you have key value pairs, a few keys basically dominate the data. Okay, so this is a little bit of easy math. So here you have a function that has a high skewness. So basically you have a long tail, okay? If you would have a Gaussian distribution, basically you would have an exponential decrease here. But if you have a long tail, there's no exponential decrease. And somewhere here sitting, actually, you still have a significant amount, in this case of maybe A's, that's much bigger than the amount of all the other keys. So if you have this problem in your data, but you still want to do something with it, and you might actually have to group it at some point, for whatever reason. There is a technique called salting. So what you do is you just basically look for the keys. In this case, let's say our skewed key is foo, and you just add a little bit of salt to it, which means you add basically a random number in a certain range. So then what you do, you have all the A's, and you transform all the A's in A1, A2, A3, A4, A5, which gets rid of the data skew, and everything is fine after you group. Because then you only group the A1s and the A2s and not the A's. And then at the end, you can basically calculate it back if you want to. Okay. Another best practice is think about resource allocation. If you start using Spark and you don't start using it with, for example, the Databricks service, which takes care for you for all of this, but you have your own cluster, or you spin it up in EC2 or whatever, you will have to specify those things. Some executors, executor cores, executor memory. I really don't want to go into detail. The only thing that you should keep in mind when you have this, actually it is good practice to stay below 5 cores per executor, because that's optimal for HDFS input-output. Plus, when you allocate memory, you should keep the yarn memory overhead in mind. Again, on this, there are many people who talk about this online. You can find many blogs about this. Any one of them really will tell you what's non-executors, executor cores, executor memory, and how you calculate the memory. So yeah, that's just something, when you hit it once, remember this, and you'll be fine. Okay, and then actually there's something I must say ashamedly realized like 2 months ago. There are window functions. So if you ever wanted to, let's say you have a data set and you have a few keys, and all of these keys, they have like values associated, and you want to sort basically the data set by keys. or you want to group it by keys, and then you want to sort it by the values, and you want to get the first value or the last value or the rank value. Doing this in Spark is not that trivial because you have to think a lot when you do the sort, when you do the group by, which means the shuffling, getting the thing basically on one executor, because you see it's all parallel. So there is actually a nice feature which is called the window functions. It's in spark.sql expressions.window. In my opinion, actually, I haven't seen many people talking about this on Stack Overflow or wherever. This is actually why I bring it here, because I feel it's heavily under-mentioned and certainly also underused, although it's one of the most useful things because there are certainly situations where you're going to use them. So if you start to read about Spark, don't use only like the aggregate kind of function that you have, but look into the expression.window. Okay, so that's from my side. That's it from my side. I hope I didn't bore you too much. I know the audience was quite diverse. I tried to have something basically for everyone. Again, I'm looking for a machine learning summer intern. Please tell people it's going to be fun. TensorFlow, natural language processing, Spark, so those are like the things we're going to do. And then also I want to encourage you to check out Tech Tuesday, of which I'm a co-organizer. It's taking place every first Tuesday of every even month. So in August there will be the next one. And it's a all thing technology meetup. Last time we had a meetup on virtual reality. Before that we had one on digital advertisement. And the next one most likely will be about blockchain technologies. So yeah, I hope you enjoyed. And of course I will make the slides available. And yeah, please feel free to ask any questions. Thanks. Yep.
You mentioned support for SparkR, the SparkR, and how does it look like with Spark devices?
Okay. So yes, for the people who are just starting with Spark, so actually there are like 4 main APIs that you can actually interact with. So there is an API in Scala, which is what I use and what you have seen. I use this because Spark is natively written in Scala. So every new kind of feature that comes up will be immediately exposed to the Scala API. There is a Java API, but I don't feel many people actually use it. There is a Python API. The Python API really is catching up. More or less immediate, yeah. So there might be a small time lag when you see new features exposed to the Scala API versus the Python API. The Python API, however, is slower. Not much, but still it is, usually. I think I have seen cases where the Python API was even a little bit faster than the Scala API for a few things. And then there is a R API, but that's very limited so far.
So overall, your impression is that Python will still be on the same level as
Scala.
Yeah.
However, so one reason actually why I chose, well, actually I'm also switching around, because the nice thing is, of course, if you use the Python API, Python has been for some years now basically the primary language of choice for data scientists. There are many, many libraries, and if it's only the matplotlib library for plotting and cool stuff, so you can directly use them, which definitely is an asset. However, when it comes to productionizing your code, so if you're not only running things for your own, but you're actually build Spark apps and you want to deploy them. For example, in our case, you want to serve recommendations, things like that. It's easier to do it in Scala because you just package up all the code in a jar. In Python, it's not that easy. So basically, yes, you can define packages, but then you have to kind of install all those packages and all the new things on actually all your cluster nodes, which is okay if you have 4 cluster nodes. It's not okay if you have 400. So if you are using the Scala API and you package it in a jar, you just submit the jar with your job, and that's fine. Yeah, but yeah. Also, if you don't know Scala, so I did not know Scala when I used it. Also, I didn't do any Java before, and as you know, Scala it basically runs in the JVM. I feel Scala is a nice hybrid between Java and Python in a weird sense. Yes, I mean, in Java you have to write like more or less everything from scratch when you do like these things. In Scala there are many kind of higher primitives, so it's nice. Yes, of course there are other differences and so on and so forth. I mean, Scala is imperative, Java is not, but yeah. Okay. Yeah, Buffalo.
Do you have experience with Spark ML Lib compared to Mahout in terms of maturity of the algorithms?
Yeah, I haven't tried Mahout, but if you, I know that if you go to the Mahout site, they will tell you, well, if you, what's implemented and even in which language and so on, if you use like Mahout in C and Mahout in Java and what's kind of there. I can't comment on Mahout, but the ML lib really is improving. So there are many new things. Also, actually, ML lib is not even the newest thing. The newest thing is like the ML, which basically also is going to be like the major machine learning library in Scala, not ML lib anymore, but ML. The nice thing is that ML supports data pipelines, very similar to the thing that you have in Python with like the learning pipelines. You can define transformers and things like this. So yeah, I don't know. Mahout, certainly one thing is that Mahout was made, I would say, from software engineers for software engineers who actually want to serve recommendations in production. So if you're doing things in production and you want to have like a huge stack of knowledge associated with it, Mahout might be, I don't know, if you know exactly what you want to do, Mahout might be the better choice because you just say, okay, Mahout, and then let's do collaborative filtering, and you can serve it easily. However, Spark, of course, gives you much more flexibility, so to say. And also it's easier for prototyping and things, I feel. Yep. Okay. Cool. So I'm going to upload the slides to my LinkedIn. So you can check them out there if you like to and share them. Yeah, and now I think we deserve a beer. So thanks for listening.